What comes next is finding the exact values of trig functions outside of Quadrant One without a calculator. Now, we haven't used a calculator a whole lot, but the problems that we just looked at, we're finding the 6 trig ratios for those specific angles that are described. What we're going to be doing in this particular unit is we're going to take that a step further, and we're just going to go straight to the point. What is the exact value of the cosine of 210 degrees? Okay, cosine of 210 degrees without using a calculator. I'm not going to use that yet. I'm going to learn that later. Okay, and what we know is, so far, here's what we know. That the degree measure, the 6 trig ratios for the reference angle have the same value as the 6 trig ratios of the angle, except for the sign. Might be positive or negative. So what's the reference angle of the cosine of 200? What's the reference angle for 210 degrees? In degrees. What's the reference angle? This is a test question, right? What's the reference angle for 210 degrees? Test tomorrow. Got some studying to do. Can't miss that one. What's the reference angle? Somebody tell me. 30 degrees. It's the closest angle back to the x-axis. All right? So if you graph 210 degrees, that's 180 plus 30 more. Right? This is a 30-degree reference angle. All right? So the cosine of 30 degrees. And I'm going to tell you that's equal to the cosine of 30 degrees because the cosine is negative in the third quadrant. Okay, so that's what we're going to use. So in order to do this, we're going to today look at special angles. 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. 95% of every problem that we work for the remainder of the year will deal with those 5 angles. The only thing that's going to be different is what quadrant we're placing those angles in. It just repeats itself over and over and over and over and over. The patterns repeat. Okay, so 0, 30, 45, 60, and 90 is what we're going to assign values to. So first of all, let's start with 0 degrees. And we're going to do all 6 trig function values for 0 degrees. And we're going to do it using the ratios. And we're going to do it by drawing a triangle that has a 0 degree angle. Okay? Now, could you actually have a triangle that has a 0 degree angle? No. Right? The triangle itself doesn't actually exist, but our calculus students will tell you that in calculus, you have to think about what happens if you get really, 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 really close to 0 degrees. That's a really small angle, isn't it? 0.000000, I don't know how many zeros that is, 1 degrees. That's a small, small angle. If I wanted 5 decimal place accuracy, what's the value of this angle? It's 0 degrees. Okay? It's a 0 degree angle. So what our triangle would look like, y'all just kind of stick with me. This is a hypothetical triangle. Be a skinny rascal. Actually be skinnier than that. This is my 0 degree angle right there. Draw it. Okay? Now, if the triangle has a 0 degree angle, right? I'm gonna do my arms like a cheerleader. Right? I'm gonna do this 0, right? Don't cheerleaders, don't y'all do something like that in some reasons. We're going to close this angle down. Our angle, right? Angles, my shoulders here, my angle is closing down to 0. If that angle is 0 degrees, then what's the length of this opposite side out here? 0, right? So the opposite side of the 0 degree angle, if the angle was 0 degrees, it has to close all the way down to 0. And when it does close down to 0, this side is going to be equal to the hypotenuse. Okay, so we've got our hypothetical 0 degree angle in a triangle. Okay, now let's use this triangle to assign values, our 6 trig ratios. Excuse me. What is the sine of 0 degrees? Sine equals opposite over hypotenuse. 0 divided by 1 is 0. The cosine of 0, that's equal to the adjacent leg over the hypotenuse. So that's 1 over 1, which is 1. The tangent of 0 degrees is going to be the opposite over the adjacent. That's 0 over 1, which is 0. Okay? Cosecant. The reciprocal of 0 is an ugly thing, right? It's undefined. Just remember the sine of 0 was 0 over 1. What's 1 over 0? It's undefined. There's no definition for division by 0. The secant of 0 is the reciprocal of 1, which is 1. The cotangent of 0 is, again, undefined. Right? So if you can draw that hypothetical triangle, you can figure these values out for yourself. Now, you're going to eventually memorize these. I'm going to ask you what the cosine of 0 is, and you're just going to know it's 1. You're going to use it that much. Okay? But this is how I want you to understand it or see it as you learn it, is this. And what we're doing is building patterns that we're going to use a little bit more later. Now, we're going to use the same triangle to do 90 degrees. Okay, here's the angle I'm going to use right here. Doesn't that also have to be 90 degrees or really, really stinking close to 90? 89.99999999999. A lot of nines. It's effectively 90 degrees, right? This is a hypothetical triangle. What's the sine of that 90 degree angle? Opposite over hypotenuse. What does that give us? Somebody tell me. Opposite over hypotenuse is 1. Cosine of 90 degrees. Adjacent over hypotenuse, 0. Okay. Tangent of 90 degrees. Okay, tangent is opposite over adjacent, right? Undefined because it's opposite over adjacent. That's 1 over 0, which is undefined. Okay, everybody good with that? Then the reciprocal of those, cosecant of 90 degrees, is 1. The secant of 90 degrees is the reciprocal of 0, which is undefined. And the cotangent of 90 degrees is adjacent over opposite, which is 0. Okay? Now, what do you notice about patterns here? What do you see? What do you see? Not a whole lot of different values we're working with here, are we? For 0 and 90 degrees, what are the possible answers? 1, 0, and undefined. That's it. You give yourself a fighting chance if you just remember that little fact. If we're talking about 0 or 90 degrees as a reference angle, the answer is 1, 0, or undefined. Okay? All right, next let's do 30 degrees. And the 30-degree triangle is going to work very closely with the 60-degree angle because both of them come from the 30, 60, 90 triangle. (30, 60, 90). So there's my 30-degree angle. Here's my 60-degree angle. And one of our triangle facts from early in the class, what are the side lengths of a 30, 60, 90 triangle? Are always in this ratio, right? 1, square root of 3, and 2. All right? So now let's do 30 degrees. To my stuff here. It disappeared. Gotta redraw it. Go ahead and start working through 30 degrees, the 6 trig ratios for 30, 60, and 90. I did it again. Gotta stop pressing that button. All right, so what is the sine of 30 degrees? Sine of 30 degrees is 1/2. Which means the cosecant of 30 degrees is 2. The cosine of 30 degrees is square root of 3 over 2, which means the secant of 30 degrees is 2 over the square root of 3. The tangent of 30 degrees is 1 over the square root of 3. And the cotangent of 30 degrees, I'm having trouble writing today, guys, is the square root of 3 over 1. All right, let's do 60. While we're here, because I've got my 60-degree angle, yes? What is the sine of 60 degrees? Square root of 3 over 2. Cosine of 60 degrees? 1/2. Tangent of 60 degrees is the square root of 3. Okay, and then the reciprocals there, cosecant of 60 degrees equals 2 over the square root of 3. Secant of 60 degrees equals 2 over 1. And the cotangent of 60 degrees is equal to 1 over the square root of 3. All right, so you can see how these two problems are very, very closely related to problem 25 and 26. We got the same values repeated over and over in their reciprocals. 1 over 2, square root of 3 over 2, 1 over the square root of 3, or vice versa. Okay, for 30, 60 angles. All right, so we've got 0 degrees, we got 90 degrees, we got 30 degrees, we got 60 degrees. What's the angle that we haven't done yet? 45. Okay, so we'll look at the 45, 45, 90 triangle to get those. 45, 45, 90 is isosceles. It's got two congruent legs. So there's 45 degrees. This is also 45 degrees, but we don't need to necessarily do that. What are the side ratios for the 45, 45, 90 triangle? 1, 1, square root of 2. All right. So the sine of 45 degrees is 1 over the square root of 2. Now this is the one trig ratio that I am going to kind of insist that we rationalize, right? The sine of 45 degrees, and you'll see why in just a few minutes, is equal to opposite over hypotenuse, which rationalizes to be the square root of 2 over 2. And I want you to remember that the sine of 45 degrees is the square root of 2 over 2. Cosine of 45 degrees, same thing, because the adjacent leg and the opposite leg are equal in this. And then the tangent of 45 degrees is the opposite over the adjacent. 1 over 1 is 1. And then the reciprocals of those, cosecant 45 is square root of 2 over 1. Same for the secant. And the reciprocal of 1 is 1. Okay? Now, I want you to kind of go back through all of the 6 trig ratios that we've looked at for all of these 5 special angles and tell me the different values that are used as answers. 0, 1, 1/2, square root of 2 over 2, square root of 3 over 2. Just for sine and cosine, that's all we got, isn't it? For sine and cosine, that's the only answers that we have. All right? And then tangent and cotangent, y'all listen to me carefully. You don't even really have to memorize those because they come from these values. Right? We just looked at, in just a few moments ago, when we were looking at those 2 homework problems, we discovered that sine is always the y value over the hypotenuse. Cosine is always the x value over the hypotenuse. And tangent is always y divided by x. So we can get the tangent of an angle just by using the sine and the cosine. So these 5 values, y'all listen carefully. Golly, I have got to stop doing that. I don't know how to undo it. That. There we go. I figured out how to undo it now. Being challenged here. These 5 values will give us every value we need for every special angle, right? 0, 30, 45, 60, 90. There's 5 special angles. There's 6 trig ratios. That's 30 values, but all 30 of those values come from these 5. All right, so if we know how that works, then we're going to be in great shape. All right, so let's put it together and find the pattern. Y'all ready? I want you to skip a line, right? Double line. So we're going to start, there's our top line, skip a line, draw another line. We're making a table. You use double lines on your paper. Make sure I get enough lines here. We're going to do 0 degrees, 30 degrees, 45 degrees, 60 degrees, and then finally 90 degrees. Now, beside that, just so we're familiar, let's put our radian measures. 0, pi over 6, pi over 4, pi over 3, pi over 2. Those are our special angles in, okay. Sine of the angle. I'll do sine first. All right, I'll give y'all a second to catch up. And we're just going to go back from those values that we just looked at and fill this table in. Now, some of you have had trig before. You're used to using the unit circle. We're going to build a unit circle later. I want you to get familiar with these values and how to do this without the unit circle because it's faster. And you're not going to be able to take a unit circle with you into the ACT or into any test that you might have to take from here on out using, trigs. You've been maybe allowed to use that as a cheat sheet before. And that's okay. And we might do that on a test at a later date. But I want you to memorize. I want you to understand and memorize these values. All right, so what is the sine of 0? From up atop, what's the sine of 0? It's 0, right? Sine of 30 degrees, it's 1/2. Sine of 45 degrees, square root of 2 over 2. Sine of pi over 3, 60 degrees, square root of 3 over 2. All right, and let's stop right there. Do you see any patterns developing here? We got 1, 2, 3, and all the denominators are 2, right? So would it make any difference if I put 0 over 2? That still has a value of what? 0. Would it make any difference if I put square roots over these two? What's the square root of 0? 0. What's the square root of 1? So I haven't changed anything, right? So do you see a pattern that emerged? Every denominator is 2. Every numerator is the square root starting with 0. Square root of 1, square root of 2, square root of 3. What would we expect the next one to be? Square root of 4 over 2, which is equal to 2 over 2 or 1. Didn't we find that the cosine, a sine of 90 degrees was 1 earlier? All right. Now let's do cosine of theta. And let's do it backwards. What's the cosine of 90 degrees? What did we find that it was? Cosine of 90 degrees is 0. Cosine of 60 degrees is 1/2. Cosine of 45 degrees, square root of 2 over 2. And we got the same pattern, right? Everything over 2, square root of 0, square root of 1, square root of 2, square root of 3, square root of 4 over 2 is 1. All right. Now, we said that the sine was related to the y-coordinate of the point, the cosine was related to the x-coordinate of the point, and the tangent was y divided by x. Okay? So if we take the sine and divide it by the cosine, we're going to get the tangent. So we can take these 5 values and we can use them to build everything. Because if we know sine, cosine, and tangent, then you just reciprocate it to get the cosecant, secant, and cotangent. What's 0 divided by 1? 0 divided by 1 is 0. 30 degrees, 1 divided by the square root of 3. 45 degrees is the square root of 2 divided by the square root of 2, which is 1. 60 degrees is the square root of 3 divided by 1. 90 degrees is 1 divided by 0. What's 1 divided by 0? Undefined. All right, calculus students, we're going to do this in table form tomorrow. If you don't know this little, how to build this, it's a real time saver. It'll help you on the AP exam. What it's going to look like, here's what it's going to look like tomorrow. This table we're going to put together. We're going to do it horizontally instead of vertically, like we just did. Angles across the top. Now don't write this down. We're going to do this in slow motion tomorrow, one step at a time. But the pattern that we recognize is that our numerators go from 0 to 4, and they're all in square roots, right? Every denominator is 2. And then cosine goes backwards. 4, 3, 2, 1, 0. And then you simplify. Okay? Now, again, not tomorrow, because tomorrow we have a test, but Wednesday we're going to look at this again. Thursday we're going to actually take a quiz on constructing this table. All right, so you want to kind of get a jump start on that. But this little table of values, all the trig ratios that we need are right there in front of us, because tangent is the sine divided by the cosine. So tangent of 0 is 0 divided by 1. 1 divided by the square root of 3 for pi over 6, etc. Okay? That's it for today.